Today we are going to talk about Floyd Warshall algorithm to solve all pair shortest path problems. It means we will have to consider every vertex to be the source vertex and find out the shortest distance from source to all other vertices. For example, at first we'll consider A as the source vertex, then B, then C, and so on. We could use this using Dijkstra's algorithm in a loop to find out the shortest path for every vertex, but the time complexity of Dijkstra's algorithm is big O of n into log 2 of n. Now, if we consider every vertex to be the source vertex, then the time complexity would be big O of n into n log 2 of n. That would mean the value of n could only be 10 to the power 3. Therefore, we would be using Floyd Warshall algorithm to lower the amount of time complexity needed. For this example, let U be the source and we want to find out the distance of U to V. We have two paths. First, the direct path from U to V, and then the K via path, where we will go from U to K, then K to V. We will update the distance of U to V only if the distance of U to V is greater than the distance of U to K with the addition of distance of K to V. To solve this given problem, we will use matrix. At first, the distance from the source A to A or B to B would be 0. And from the source to any other vertices, the distance would be infinity. Here in the first row, A is the source. So the distance of A to A is 0, and at first the distance of A to all other vertices would be infinity. Similarly, for row 2, B is the source vertex. So the distance of B to B would be 0, and the distance of B to any other vertices at first would be infinity. Similarly, we have written down the distance of all other vertices. This matrix D represents the direct distance of the vertices. So let's update the distances according to the graph. So the distance of A to B is 4. So let's update from A to B 4. Then B to D is 6. So let's change this. D to E is 4. So D to E is 4. E to D is 2. So let's change the value to 2. Similarly, let's update all other values. So we are done updating all the values. Now let's move to the next matrix. dA is another matrix where we will calculate the shortest path considering A as the via vertex. Before manually calculating, we can apply few shortcuts, like the diagonal distance will always remain 0 because the distance of the source to itself will always be 0. Secondly, whatever the via vertex is, the value of their row or column will not be changed. In this case, the row and column of A will not be changed. I'm referring to this row and this column. It's because A itself is the via vertex. We know the condition of updating the distance is if the distance of UV is greater than the distance of U, K and the distance of K, V. Here U is A and the y vertex K is also A. So the condition would look like this. Dist of A, V greater than dist of A, A plus dist of A, V. We know the distance of A to A is always 0. So dist of a comma v will never be greater than dist of a comma v. Therefore, the value will remain unchanged. Another trick is if there is an infinity in the y vertex row or column, we will not change the value in the corresponding column or row. For this trick, u and v can be any vertex and the y vertex k is equals to a. So the condition would look like this. Dist of u comma v greater than dist of u comma a plus dist of a comma v. If there is an infinity in the row of a, then dist of u comma a would be infinity and nothing is greater than infinity. So the value will remain unchanged. Similarly, if there is an infinity in the column, then the term dist of a comma v would be infinity. And so again, nothing is greater than infinity. The value will remain unchanged. Now let's begin the actual calculation. By applying the tricks discussed, we will not change the values in the highlighted cells. So let's calculate the value of this cell. Dist of C to B. We have to check whether dist of C to B is greater than dist of C to A plus dist of A to B. The distance of C to B is infinity and the distance of C to A is 2 and the distance of A to B is 4. So infinity is greater than 6, so we'll change the value from infinity to 6. Now let's calculate the value of this cell. So dist of D to B, we have to check whether dist of D to B is greater than dist of D to A plus dist of A to B. Dist of D to A is 1 and distance of A to B is 4 and distance of D to B is infinity. So infinity is greater than 5. So let's update the value from infinity to 5. And now we have to calculate the distance of this cell via path A. So distance of C to E, whether this is greater than distance of C to A plus distance of A to E. So the distance of C to E is 3 and the distance of C to A is 2 and the distance of A to E is 5. Now this isn't greater, rather this is smaller. So we will not be updating the value of this cell. Now let's write down the final values of matrix dA. So the column of B and the row of B will not be changed. And if there is an infinity in the row of B, meaning this column and this column, the values will remain unchanged. And since in the column of B, here we got an infinity, so the corresponding row will remain unchanged. And the values in the diagonal cells will not be changed, so we'll highlight this cell and this cell also. Now let's calculate the remaining cells value. So dist of A to C infinity and dist of A to B, since B is the Y vertex plus dist of B to C. Dist of A to B is 4 and dist of B to C is 1, which is greater than the value 5. So let's update the distance from infinity to 5. Then for this cell, let's replace C with D. So the distance from A to D is infinity. A to B remains 4 and the distance of B to D is 6. So 10. Infinity is obviously greater than 10, so we will change the value of this cell also. Now let's calculate the distance of this cell. So dist of C to D is infinity and the distance of C to B is 6 and the distance of B to D is also 6. So infinity is obviously greater than 12. So let's update the value from infinity to 12. For this cell, we will calculate the whole thing again. Distance of D to C. So distance of D to B, then distance of B to C. Value here is infinity. Distance of the value of distance of D to B is 5 and B to C is 1. Infinity is greater than 6. So let's change the value from infinity to 6. This is our final DB matrix. Let's write down the final values of DB matrix into DC matrix. According to the tricks, the highlighted cells values will not be changed. So let's calculate the distance of all other cells. Now let's calculate the value of this cell. So distance of B to A via C path. So this of B comma C plus dist of C comma A. The distance of B comma A is infinity. The distance of B comma C is 1 and the distance of C comma A is 2. So infinity is greater than 3. So let's update the value from infinity to 3. I hope by now you have understood how this algorithm works. So I will be fast forwarding these calculations. So the matrix DE contains the final all pair shortest path distances, and this is exactly how the Bellman-Ford algorithm works.